Hello guys, welcome again. I am Mr. Mohammad Shahbaz Alam from ABES Engineering College. In the previous lecture, we have discussed the breakdown mechanism and Zener diode as a voltage regulator. Now, in this lecture, I am going to discuss three special purpose diodes, that is light emitting diode, Varactor diode and tunnel diode. First of all, the light emitting diode. All of you guys use various types of LEDs, especially in our Diwali festival. In our buildings, we use various colors of lights. Then question arises that how light emitting diode works. इसमें लाइट कैसे निकलता है और अलग अलग तरह का लाइट कैसे ये इमिट करता है, क्या इसका डिजाइनिंग नॉर्मल डायोड के जैसा ही है या नॉर्मल डायोड के तरह ही है, उसके अलग है, या इसका वर्किंग नॉर्मल डायोड की तरह है या नॉर्मल डायोड से अलग है. तो आई विल डिस्कस ऑल दीज पॉइंट्स. गाइस, लाइट इमिटिंग डायोड आर डिजाइन्ड और मैन्युफैक्चर्ड सच अ वे दैट इज देयर मस्ट बी द ऑप्टिकल confinement, and there are various colors diodes available, and the working principle of diode is same as the general purpose diode, but the difference is that in general purpose diode, when the electron occupy the holes, they will radiate the heat, they will radiate the power in terms of heat, but in LED the radiation is in form of photons h nu. And if the frequency changes or terminal voltages changes or the material used to manufacture the diode to design the diode to form the diode will changes, the color will also changes, and this is the symbol of light emitting diode, just emits the diode if, and this is the physically available diode. Okay guys, now light emitting diode. So light emitting diode is a diode, especially it works in forward bias diode. In forward bias diode, the intensity of the light increases when the forward current increases. This means forward current will increase when the forward voltage will also increase. Then what is the working principle of this diode? Before discussing the working principle of light emitting diode, this is the three types of material used to construct or used to make made the LED. Gallium arsenide. Gallium arsenide diode material is used to radiate the infrared, and you guys know where infrared LED is used, especially in case of remote. In case of remote, the infrared LED is used in generally. And now gallium arsenide phosphide, GaAsP, red or yellow, and on the other hand gallium phosphide, red or green. You guys may think that why the same material can radiate two types of color. It is very simple. All of us know that the frequency is proportional to the energy and energy is proportional to the voltage. If we will change the terminal voltage of any LED, the color may change, because for red color the terminal voltage will be low, and for the yellow color the terminal voltage will be high, because for high energy there should be the high voltage, and all of us know that the energy of the yellow is greater than the red. So this means what will happen, if we change the terminal voltage, the color of the LED may change. But in case of gallium arsenide, this is the red or green. Just the answer is that by changing the terminal voltage, the color of the LED will be changed. All of us use this phenomena in Diwali also. Now, working principle of LED. I am going to discuss the working principle of LED in this graph. What will happen? Guys, all of us know that in n-type semiconductor, electrons are in the conduction band, that is at the higher energy level. On the other hand, in the p-type semiconductor, holes are at the valence band, that is at the lower energy level. When electrons cross the junction, this means when electron shift from the conduction band of the n type to the conduction band of the p type, then the electron will falls into the valence band. This is called the recombination of electron hole pair. Due to recombination of electron hole pair, when electron falls from the higher energy, this is conduction band, into the lower energy to occupy the hole, that is the lower energy, then it emits the energy. All of us studied in 11th class in chemistry that when electrons falls from the higher orbit to the second orbit, it radiates the Balmer series, Paschen series, Brackett series, P-Fund series. There are various types of radiations. In the same way, in case of LED, when electron falls from the conduction band to the valence band to occupy the hole, it radiates the energy in forms of photon, and that photon is called the color. And in the same figure, I am going to also discuss, this is the phenomena to radiates the color. Electrons falls to the valence band and it radiates the emits, that is the photon. Okay guys, ये phenomena diode में भी होता है, but there is not photon, there is the heat, there is the other form of energy. In normal diode, the energy radiates is not in the form of photon, but in case of LED, the energy radiates is in form of photon. Now, the structure of LED, the structure or designing of the LED is known as the layered structure. This is the layered structure of LED. This is basically the P type semiconductor, and this is the N type semiconductor, and this is called active region. Why it is called active region? Because through the active region only diode, only photons radiates, only light radiates through the active region. That is why the region in between the P type and N type is called active region, and this is the anode terminal and this is the cathode terminal. There are two terminals, anode and cathode. When we will apply the voltage, plus voltage and minus voltage, then what will happen? The recombination of electrons and holes will occupy, and the energy will emits through the active region only. Now, how the LED are available in the market basically. This is called dome structure. This is the dome structure. Dome structure is nothing. This is the, suppose this is the cathode and suppose this is the anode, longer leg is anode and this is the layered structure. This structure is here, is kept here. Okay guys, this is P type, sorry, this is N type and this is P type, and this whole structure is kept in the glass envelope, and this is the active layer and this is the dome structure of the LED. Okay guys, this is the dome structure of the LED. Now, advantages of LED. This is the advantages of LED. The brightness of the light emitted by the LED depends on the current flowing through it. This means I am going to design, suppose this is the forward voltage and this is the light, LED light emitting diode, and this is the resistance R. This means if this is the forward voltage and this is the light emitting, this means the intensity of the light, intensity of light is proportional to the forward current, and this is the forward current. I am going to draw a graph also. Here graph, you can see that. This is the forward current and this is the light, and I am going to 3 graph here. This is R1, this is R2, this is R3. Here R3 is less than R2 is less than R1. Less than R1. This means if the value of resistance will decrease, the forward current will also increase. Forward current will also increase. If R decreases, then forward current increases. This means the light will increase suddenly. So this is the relation between the forward current and light with the various value of the resistances. Now, application of LED. There are various applications in the alarm system, calculators, picture phones, traffic signals, digital computers, multimeters, microprocessor, digital watches, automobiles, camera flashes, and other are the optical fiber communication and 7-segment display, traffic lights. There are various applications of LED. In case of LED bulb, we are using in our houses or in our classrooms LED bulbs. So, there are various applications of LED we can show. The famous application of LED is the 7-segment display. This is the 7-segment display. We always use this in any digital display. This is called A, B, C, D, E, F, G. This is the 7-segment display. Now, the another diode is the tunnel diode. Tunnel diode. In tunnel diode, basically there is a tunneling effect, and this diode is the most doped diode. The tunnel diode is heavily doped diode, p-n junction diode. The tunnel diode shows negative resistance region. When voltage value increases, current flows decreases. Tunnel diode works based on the tunneling effect. This means there is a negative resistance region in case of tunnel diode, and if any device consists of negative resistance region, that device may be used as an oscillator. Now, Leo Isaki invented this diode in 1957. That is why this diode is also known as Isaki diode, and this is the symbol of tunnel diode, and this is the physical form of the tunnel diode, which is available in maybe in your college laboratories. Now, depletion layer of the tunnel diode. Due to very high doping, impurities added, the width of the depletion layer is very thin, narrow as compared to the general diode. Therefore, when a small amount of voltage is applied, it produces enough electric current in the tunnel diode. Tunneling effect. In electronics, tunneling is known as the direct flow of electrons across the small depletion region from N side conduction band into the P side valence band. And a tunneling effect is the direct conduction of electrons through a small depletion layer. Why small depletion layer? Because tunnel diode is very highly doped diode. That is why the depletion layer is very narrow, and the flow of electrons is easily possible from the N side to the P side at the low forward voltage, and this phenomena is called tunneling effect. Now, this is the pictorial representation of the conduction band and the valence band, and these are the electrons at the conduction band of the N type, and these are the holes at the valence band of the P side, and the valence band and conduction band of these two layers are almost at the same level, and the electrons easily tunnel this depletion layer, this barrier, and occupy the holes, and this phenomena is called tunneling effect. Now, working of the tunnel diode. I am going to discuss the working of the tunnel diode in various phases. Now, case 1, when small voltage applied to the tunnel diode. When small voltage applied to the tunnel diode, then the majority carrier will conduct from the N side to the P side, and a small current will starts flow. You can see in this figure that the upper electrons are at the same level of the valence band. This means this electron will easily move from the conduction band to the valence band of the P type. So, some electrons will conduct so that a small current will starts flow. Now, case 2, increase the applied voltage. Then what will happen? When we will increase the applied voltage, this means the valence band level will increases. The valence band level of the P type will be shifted upwards. Then now a large number of electrons will conduct from the N side to the P side, and a high value of current will achieve. This means in this condition the maximum value of the current will achieve here. then what will happen now? Further increase the value. If we further increase the value of the forward current, what will happen? Already the maximum number of majority carrier has already conducted from N side to the P side. Here due to here, if we increase the voltage, then what will happen? Instead of increasing the current will start decreasing here. This means the anti-Ohm's law. This means if we will increase the voltage, the current will decrease. That is why this is called anti-Ohm's law. And what will happen? Largely increase the voltage. If we will largely increase the voltage, then what will happen? We will achieve this curve like this. First of all, the current will decrease to the bottom, and further then current will increase. And after this voltage, this valley point, the curve or the characteristics of the tunnel diode follows the general purpose diode. This means just as the normal diode. If we will discuss the value of the forward voltage here, basically this voltage is 0.07 volt and this voltage is 0.7 volt if the tunnel diode is made up of silicon diode. This means the peak current is already achieved at the 0.07 voltage only, and in between the peak value, peak point and valley point, this is the negative resistance region. Why this is negative resistance region? Because voltage increases but current decreases, and this negative resistance behavior is used for designing the oscillator circuit. Now, the equivalent circuit of the tunnel diode. This is the equivalent circuit of the tunnel diode. This is the series resistance 1.5 ohm. This is the minus Rn due to the negative resistance region 152 ohm, and this is the series inductance, and this is the 6 nanohenry, and this is the capacitance and 5 picofarad. And the tunnel diode will work like that as this circuit will work. That is why this circuit is called the equivalent circuit of the tunnel diode. यानी ये सर्किट जो RLC सर्किट है जिस तरह से काम करेगा उसी तरह से एक टनल डायोड भी काम करता है. That is why this circuit is called the equivalent circuit of the tunnel diode. And this is the VI characteristics of the tunnel diode, guys. Already we have discussed. This is the curve, and we can see in the reverse bias that it cannot hold the reverse voltage. As we apply the negative voltage, it gets breakdown. This means it cannot hold the reverse voltage. This means we cannot use the tunnel diode for the rectifier circuit or for the rectification purposes. And this is the VI characteristic of tunnel diode, and this is the peak point, and this is the valley point. In between the peak point and valley point, this is called the negative resistance region. Already I have discussed. Now, application of tunnel diode. Tunnel diode can be used as a switch, amplifier and oscillator. Since shows the fast response, it is used for high frequency component. Tunnel diode acts as a logic memory storage device. They are used to oscillator circuit and in FM receivers. Since it is a low current device, it is not used more. ये इसका एक बिल्कुल स्पेशल पर्पस होता है. आप ओसिलेटर की तरह यूज कर सकते हैं, आप हाई स्विचिंग डिवाइस की तरह यूज कर सकते हैं, आप डिजिटल डिवाइसेस में यूज कर सकते हैं बिकॉज इट हैज हाई फ्रीक्वेंसी एप्लीकेशंस. नाउ वैरेक्टर डायोड. Varactor diode. Already discussed that Varactor diode is used as a variable capacitor diode, and this is the symbol of the diode. This is the capacitor basically, and this is the symbol for Varactor diode, variable capacitor diode, and this is the physically available Varactor diode in our laboratories or in market for laboratory as well as commercial purposes. Now, description of the working of Varactor diode. All of us know that the working of Varactor diode is just as simple as the normal diode works. Basically, we use the depletion layer of the PN junction diode as a parallel plate capacitor. What is parallel plate capacitor? I am going to explain it in detail. Suppose if this is the parallel plate capacitor, then what will happen? If we apply here positive supply and we here negative supply, then what will happen? The positive charge will storage at the right plate of the parallel plate capacitor, and negative charge will store at the left plate of this plate. And if the suppose the distance between these two plates is d, then what will happen here? It is very simple that the parallel plate capacitance is the A epsilon by D, where A is the area of cross section and E is the permittivity of the medium, and D is the distance between the two plates. And this is just analogy with the depletion layer of the p-n junction diode, or you can say Varactor diode, because at the N side, suppose this is P side and this is N side, when we apply reverse voltage, what will happen here? Here it is the immobile positive ions are here, and here the immobile negative ions are there. Here, this means the positive charge, immobile positive charge and immobile negative charge are separated by a small distance, and that distance may be known as the width of the depletion layer. And this capacitive behavior and this capacitive behavior both are almost same. For the parallel capacitor, this is the capacitance formula, but for the transition, and this capacitive behavior is called transition capacitance, and transition capacitance is equal to the K upon Vr plus Vk whole raised to the power n, where K is the proportionality constant, where K is the proportionality constant and Vr is the reverse voltage and Vk is the knee voltages. Now, we can write this equation as this. Okay guys, we can evaluate that Ct is equal to K upon Vr plus Vk whole raised to the power n. I am going to take the common here Vr, K upon Vr into 1 plus Vk upon Vr whole raised to the power n. At reverse voltage is equal to 0, the Ct is equal to C naught, and C naught is equal to K upon Vk raised to the power n. So, this is the transition capacitance, and we can write in the same formula here, and this is the graph between the transition capacitance or Varactor diode capacitance and between the reverse voltage. C is equal to K upon Vt, Vt is the nothing, this is the Vk, basically knee voltage, and 1 plus Vr upon Vt whole raised to the power n. So, the capacitance, transition capacitance is in the form of transition capacitance. So, okay guys, this is all about the discussion of various special purpose diodes, and we have already completed the unit 1 and unit 2 in 11 lectures, and in the next lecture we will discuss the next unit, that is the unit 3, transistors. Okay guys, see you again.